the helmet at the image will be clear, will be seen clearly, and the classifier then used the weight and dimension to detect whether there is helmet or not. And this is the PCA we used to detect the helmet. And the first read image, okay, that what we get the image from previous from the previous method, then and we get the image, I mean the written image. So the image used to go to find whether there is a helmet or not. The first is calculate the average factor and determine the difference with the original value, and then calculate the covariance matrix or its alternative, and then determine the eigenphase of eigenvalue and eigenvector, then calculate projection for its image. Get to know the helmet image or helmet, no or yes, you get an end. This is the first of the PCA. Import the training images. This is from the sample. There is 253 sample of the training images. We sorted the first images until the end of the images at the 253rd. Then the pixel value, we use it to the next step, and then count the average image. Count the average image from the previous step. We call that as M symbol, and then find the difference between the original value and the average value. Subtract it, and the entire difference between the original value with the average value is put together in a matrix based on the column, and we put it in a matrix A, and then calculate the covariance matrix. Because the dimensions are too large, then use the alternative, the A transpose. We use it to multiply to multiplicate into the A, and then we put that into variable L, then find the determinant as what we have known how to find the determinant. So on the eigenvalue, we find it, the eigenvalue, and then we get the eigenvector. Then the next is do a multiplication between A and B to get U, the variable U. Okay, and testing the application of PCA to detect the presence of helmets uses one of the test image samples with the following matrix. then we use the sample uh, so that we can know how to find whether there is helmet or not. And the next step is the test sample matrix above. Then find the difference with the average image. The average image uh, is right here. Okay. Then okay. Then calculate the projected test image by subtracting the transpose matrix from eigenphase, with the matrix resulting from the reduction of the test image with the average image. Okay, we find it. So the projected test image will be used to find the distance with the Euclidean distance calculation. And then calculations continues until the Euclidean distance values are obtained between the test image and the entire training data. Then look for the minimum value of the entire distance. Then it is found that the minimum value is at D171, which is equal to 6.0994E15, and the data 171 is in the range of labels that is classified as no helm. So it means then the test data is classified into images that are not helmets. The classification succeeded in detecting precisely that the test sample was indeed not a helmet, so it was included in the true negative evaluation value. This is the result type over the testing. Model 1 face detection, helmet detection, and Model 2 histogram localization, face detection, helmet detection. Model 3 Bicubic interpolation, histogram localization, face detection, and then helmet detection. We mean we divide the type of testing into the three model, and all of the three models have a different step. And the first without histogram equalization and also without Bicubic interpolation. The second model we use histogram equalization at the first, so then we will see the difference. At the model 3 we use the Bicubic interpolation, and then we use also the histogram equalization. Then we will see the difference and compare one to another. And this is the result of model 1. This is the classification process, the classification process of model of the first model. This is the face detection and helmet detection without any increment method. I mean, with another method. Then this is the result, classification result of the first model, the Viola-Jones at 89% of accurate, and the PCA 75. And then the second model, the classification point of model of the first of the second model, then we use the histogram equalization, and then we get a face detection. You know that the face detection is more accurate since at, at the first model, the face detection is just a very little face can detect. Uh, but at the second model with histogram equalization, the 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 face is more detected, more even uh, much more detected, much more easy to detect it by the classifier. And this is the result of the classification of the model of the second model. Uh, there, the PCA at the number at the percentage 79 of accuracy. And then, but the third model, we used a bicubic interpolation, and we can see that the button no helm, no helm, no helm, no helm, helm, no helm, no helm, helm, no helm. Then, if we looked at the previous model, I mean the second model, the classifier, the classifier would be wrong, since this is a helmet, but it classified as no helmet. And if the third model, it classified, it's really correct classified. Helm classified as helm. Okay, and this is the result of the classification of the third model. And the PCA at the 82% accuracy. Viola-Jones at 95% accuracy. Okay, now we jump to conclusion. In principle, methodologically, the helmet detection process begins with face detection. Face detection uses the Viola-Jones method. Then, the detected face positions are used as a reference points by the PCA to detect helmets. The results show that in the initial image, several faces and helmets failed to be detected. This is due to poor image contrast. Increased contrast with the histogram equalization method has a positive effect on face and helmet detection. For face detection, the accuracy of 89.55% increased to 92.36%. And for helmet detection, the previous accuracy was 75%, increasing to 79.37%. The results of image processing with histogram equalization show that there is still a face or helmet detection that failed. That's because the scaling results are still not good. So that in these results, the bicubic interpolation process was carried out to improve image quality, which at first detected face detection at an accuracy of 92.36%, then 95.52%. And for helmet detection, the initial accuracy is at 79.37%, increasing to 82.81%. Good pixel values caused by a combination of histogram equalization and bicubic interpolation make Viola-Jones more accurate in detecting faces, while making PCA better at detecting helmets. Helmet detection failure occurs due to the similarity between helmets in the dataset with some head shapes that are analyzed through the results of calculations on the pixel values of images in the head region.